So I'd like to continue on and with one more geophysical application, and this is measuring or modeling the temperature distribution surrounding a deep sea hydrothermal vent. Now the hydrothermal vents are roughly 2 kilometers underneath the surface and also form the basis of extremophile food chains in regions where there's absolutely no sunlight whatsoever. So the model that we have here, we're going to simulate the black smoker chimney of a length of roughly 1 meter with a chimney diameter of 0.1 meters. The basalt temperature is roughly between 3 and 400 centigrade, with the water temperatures between 2 and 3 centigrade. Now there are obviously convection processes that are occurring here, and this is a little bit more expanded region showing the magma and the circulation of seawater that's occurring here. So, and also there is convection of the seawater as it's moving over the hydrothermal vent, bringing a whole soup of chemicals, various chemicals that are, some of these are forming the basis for the food chains that we see next to these type of objects, including tube worms and crabs and a great diversity of life surrounding these things. So let's go ahead and open the QuickField model. And once again, I'm simulating this in axial symmetry. And I'll go ahead and make this full screen and look at the properties, the chimney properties here. So this is steady state heat transfer and axisymmetry. And I'll look at the block labels. This is the seafloor. And I could have rounded this a little bit more. This is rather rectangular chimney. Thermal conductivity I specified as 2 watts per meter Kelvin. The water has a thermal conductivity of 0.563 watts per meter Kelvin. Now I've selected some boundary condition. The sea temperature in the background is 276 Kelvin, okay, 2 or 3 degrees centigrade. And the vent feature here is roughly 300 Kelvin greater than that, so 626 Kelvin for the geothermal vent. And I've assigned a boundary condition to the interior region. And now we can solve the solution here. And this shows us a contour map of our temperature surrounding the geothermal vent. And I can zoom in here. Also, we can make contour plot of the temperature along any contour and the vectors of heat flux. You can see that are flowing away from the vent feature here. So this concludes the geophysical portion of the presentation, and now I would like to look at some astrophysical problems that we can model in QuickField.